Welcome to the Power of Scripting, brought to you by IBM. In this course, we'll learn about the history of scripting and review the most popular scripting languages. We'll then get hands-on with Python and learn how it's used in cybersecurity. Let's get started. Welcome to a history of scripting, brought to you by IBM. In this video, we'll be discussing the history of scripting languages and their common uses today. Scripting has been with us all along with computers. In fact, scripting was the only way to use a computer back in the early days. In the 1950s and 60s, programmers submitted punch cards to mainframe operators, and the machines ran in batch mode. IBM's Job Control Language, JCL, is often cited as one of the first scripting languages. But while scripting languages were functional, their response time wasn't nearly as fast as modern computers. It often took at least a day to get any results. For both DOS and the OS, the unit of work is the job itself. A job consists of one or several steps, each of which is a request to run one specific program. For example, before the days of relational databases, a job to produce a printed report for management might consist of the following steps: a user-written program to select the appropriate records and copy them to a temporary file, sorting the temporary file into the required order, usually using a general-purpose utility, then a user-written program to present that information in a way that's easy for the end users to read and includes other useful information such as subtotals, and a user-written program to format selected pages of the end user information for display on a monitor or a terminal. Originally, mainframe systems were oriented towards batch processing. Many batch jobs required setup with specific requirements for main storage and dedicated devices such as magnetic strips, private disk volumes, and printer setup with special forms. JCL was developed as a means of ensuring that all required resources are available before a job is scheduled to run. For example, many systems such as Linux allow identification of required datasets to be specified on the command line and therefore subject to substitution by the shell or generated by the program at runtime. On these systems, the operating system's job scheduler has little or no idea of the requirements of the job. In contrast, JCL explicitly specifies all required datasets and devices. The scheduler can pre-allocate the resources prior to releasing the job to run, which helps avoid a deadlock of sorts. The first interactive shells were developed in the 1960s to enable remote operation of the first time-sharing systems, and these used shell scripts, which controlled running computer programs within a computer program known as the shell. Calvin Moores, in his track language, is generally credited with inventing command substitution, the ability to embed commands within scripts that then interpret and insert a character string into the script. When these interactive time-sharing systems started to be developed in the 1960s, the idea of scriptable shells came into practice. One of the earliest was the Multics project. When a few Bell Lab programmers pulled out of the project, they decided to implement their own system, which they dubbed Unix. One innovation of the Unix shells was the ability to send the output of one program into the input of another, making it possible to do complex tasks in one line of shellcode. Other scripting languages have followed in the Unix world, such as AWK and SED, for manipulating text. To discuss how scripts are currently used today, I'm going to turn it over to Raul, who's with IBM Security.
What do we use scripts for? Scripts are automators. We have a task and we don't want to write a command for each task every time, especially since writing a program will take us around 10 minutes to 2 weeks, depending on the complexity of the task. So we need to write a program that will allow us to call him every time that we need a task to be performed on a certain database, certain set of files. So yes, the name of the game is automation. So basically right now, we use scripts for commerce. When we see those image rollovers where you want to see an item, to check a bigger picture, that's in a script. Validation. If we are being requested to fill out our credit card in a field and we try to put our name in there and the field says no, I need credit card number, that validation is done by a script. Database backups. We don't want to be manually tied to a computer when we need to perform a backup. We use scripts for the backups to be done at certain time to a certain hard disk. And testing. We might have a human to perform tests one and over again. But why? We use scripts to perform the testing automatically.
Welcome to Scripting Concepts, brought to you by IBM. In this video, Raul will be taking us through the different concepts related to scripting languages. Let's get started.
A script is basically a program. There is a difference, a basic difference in which a script is not translated to machine code. It depends on an interpreter program that will run a script line by line. But other than that, it has the same functions, procedure. It can have external calls. An external call is um, reference to another program, in this case, another script that will be run from the original script and will add its output to the script that we're running and the standard variables and constants. Let's see some examples. Most scripts depend on variables to be able to perform its output. A rule of thumb is most scripts, just as almost every program languages. I'll say that again. A rule of thumb is that most script interpreters, just the same as most program languages, need its variables defined. Now, that doesn't happen in script languages like Bash, but in Windows, yes, you need to declare the type of the variable you're using. What does it mean? What does mean declaring? It means that if you're going to store text into a variable, you need to tell the scripting interpreter that you're using it for text. Otherwise, if you are using a variable for numbers and define it as text, you won't be able to use any mathematic functions on that variable. It will give you an error. Now, for space efficiency, most variable types have already a set memory size. That happens for most programming languages and most interpreters. Bash uses a pointer memory type, so it doesn't use size for its variables, but that's an exception. Now, these variables, what can I do to them? I can assign a value, I can reference, manipulate, replace, or at the end of the program, delete the variable. Now, there is a special kind of variables called arguments or parameters. What happens with this? It's exactly why scripts are so interesting. When we're calling a script, we can tell name of the script, let's call it backup. And then in the command line, we can tell it backup this database. Now, inside of the script, we're going to program that variable that comes after the name of the script as a parameter. Basically, a parameter is something we add at the beginning of the script execution as part of the script calling that we will be using to perform the script. It will be either the target or it will be one of the commands or operations that we are going to perform on the target. Now, the if statement is the lesser definition of a decision inside of a script. It will give us a structure to decide if we're going to perform one operation or another inside of a script. The normal definition of an if statement will be if, and then we're going to establish a condition that will be one state or another, true or false. Then what is going to be performed if that condition comes true or else, that is the text, the code that will be executed if the condition comes as false, and the end of the if statement. When performing repetitive tasks, we are going to face situations when a task has to be repeated by a number of times. Sometimes we will know how many times we have to repeat the task. Sometimes it will come as a parameter, or sometimes we will have a list of items. We don't know when we are writing the script how many times is it going to be repeated, but there is a variable or a list of variables that will determine that. So we will create a loop. The three loops defined in almost every programming language are: for loop is going to be evaluated at the beginning of the loop. It will perform the loop for an already determined number of times or determined by a variable. The definition will be for counter to limit to the code that is going to be repeated and end. The next one is the while. A while loop is set while a condition is true. So it could be set a sensor, then while sensor is called, do a series of tasks to heat up the sensor, end. So this loop will be repeated while the condition is true. And the until loop, which it has been deprecated, but it's nice to know. The until loop is evaluated at the end of the loop, trying to determine if a condition is true at the end of the loop. So there's nothing an until loop can do that a while loop cannot do.
Welcome to Scripting Languages, brought to you by IBM. In this video, Raul from IBM Security will be taking us through the different scripting languages.
Okay, JavaScript is an object-oriented scripting language. It was developed in the 1995 by Netscape Communications. Now, Netscape Communications was very close to Sun Microsystems at that time, and Sun Microsystems was one of the biggest backers of the Java programming language. Web pages at that time were very plain, and even animated GIFs were in development. So, to perform a series of behaviors that will allow pages to be more interactive, and a scripting language had to be developed. So Netscape took the vanguard and they spearheaded the creation of this scripting language. Now, JavaScript was designed to be run in almost every environment. It is lightweighted, is protected, it won't allow people to use or share resources with the server. The programming language does not allow any input-output, such as networking storage, between the server and the client machine. Basically, what it will run on the client machine and keep it as we can call it a prison environment. Variables on JavaScript can be defined using the var word or a constant. We can also let name of the variable that will declare the variable. We can assign the variable with number or any kind of value. We can use let y equals IBM, and that will be the value inside of the variable. Or we can even declare a full string. Let y equals hello world. Please check that any text is declared between brackets. And the definition has to end with a semicolon. Bash scripting. Bash is a shell created for Unix. A shell is basically the program that allows us to communicate with the operating system. Bash includes an scripting interpreter that will allow us to create small single programs to perform a whole variety of functions. If we want to create a list of users in Unix, we can create a bash script that will create them for you. As an example, variables in bash are pretty simple. We just write the name of the variable, the equal symbol, and then we assign a value. That's it. Afterwards, what do we do to reference a variable? We call it with the $sign symbol. Afterwards, inside of a script, we can create as many variables we want, and then we just call them inside of the script. Perl is a scripting language created in 1987. It's used for scripting between client server, and there is a lot of usage today for Perl, especially in web pages. It creates very interesting functionality, and it rivals JavaScript in folders. It's a little bit more complicated, but the Perl evangelists are very loyal to the language, and there is a lot of resources on the internet if you want to learn about Perl. Just as Bash, variables in Perl do not need to be declared. The difference is when we are declaring a variable in Perl, we have to use the $sign to tell the interpreter that we are going to use a variable. PowerShell. Windows did not use an scripting language until 2016. That is almost what, a good 20 to 30 years to the other operating systems. So PowerShell is basically an interpreter that is run on .NET that will allow us to perform basic scripts in Windows. We can perform file operations. We can perform even network operations. Binary code is what we call machine language. It is what the compiler will do to any programming language. Actually, scripting in binary is no easy task and is done specifically for certain tasks. Binary scripting is used mostly in telecommunication and in binary encoding when we are writing CDs and DVDs, or when we are cloning a storage system. The idea of binary is that there are only two states, 0 and 1, and the space in memory to store this state is the smallest type in computing, is the bit. So in data transmission, the bit is the measure to calculate data transmission bits. So as you may see, this is not a language that you will be using most of the time. The idea to add a binary payload into a shell script would be to use a smaller packet to overwrite a library or a file in a program you either wrote or you are updating. But this is also done by using hexadecimal scripting, which is easier to read and write, which is where we're going right now. Hex scripting. Hexadecimal scripting is mostly mathematical. It's an easier way to read machine language and is used mostly when you're updating a software. Overriding numbers is faster than than decrypting the machine code we already compiled, make the change, and recompile it. Most software companies update your software by overriding the hex numbers in the files. So it can be done. Also, it can be used to monitor some values and get to know which are some changes that the program is doing in memory, and for troubleshooting and debugging. It's very unlikely that the average computer engineer will be using hexadecimal code most of the time, unless you are a very specialized debugger or you're a programmer debugging a execution program, something like that. That's what I can tell about hex scripting.
Welcome to Shell Scripting Basics. After watching this video, you will be able to outline what a script is, list use cases for scripting, describe the shebang interpreter directive, and create and run a simple Hello World shell script. A script is a list of commands that can be interpreted and run by a program called a scripting language. Commands can be entered interactively at the command line or listed line by line in a text file. Scripting languages are usually not compiled. They are interpreted at runtime. Scripts are generally slower to run than compiled languages, but they are also much easier and faster to develop. Scripts are widely used to automate processes, such as ETL jobs, file backups and archiving, and general system administration tasks. You can use scripts for nearly any computational task, including application integration and plugin and web application development. A shell script is an executable text file in which the first line usually has the form of an interpreter directive. The interpreter directive is also known as a shebang directive, which has the following form: #bang interpreter plus an optional argument. Interpreter is an absolute path to an executable program, and the optional argument is a string representing a single argument. Shell scripts are scripts that invoke a shell program. For example, #bin/bin/sh invokes the bourne shell or other compatible shell program from the bin directory. #bang/bin/bash shebang invokes the bash shell. Shebang directives aren't limited to shell programs. For example, you could create a Python script with the following directive: #bang/user/bin/env python3. Here we demonstrate how a shell script can be used to run a program with a simple Hello World example. From the command prompt, you can create a simple Hello World shell script as follows. Use the touch command to create an empty text file called helloworld.sh. The .sh extension is a convention used to indicate that the file is a shell script. Now, turn your text file into a bash script by echoing the bash shebang and appending that echoed text to your file using the double greater than symbol, which is the bash output redirection operator used for appending output to file. Finally, use the echo command to print the statement echo hello world and again redirect that output to your bash script. Before you can run your bash script, you need to make it executable. First, check the current permission settings of your script by using the ls command with the -l option. The R and W entries indicate that the script is readable and writable, but the lack of an X means it is not executable. The R, W, and X entries apply to 3 user-based permission groups: the owner, which is you, the group, and all users. You can make it executable for all users by invoking the chmod command with the +X option. Checking the permission settings now shows that your script is executable for all users due to the X entries for all 3 permission groups. Now you can finally run your bash script by typing ./helloworld.sh and pressing enter, and the text Hello World appears on the command line. In this video, you learned that a shell script is an executable text file that begins with a shebang interpreter directive. A shell script can be used to execute commands as well as run other programs. Scripting languages are not compiled, they are interpreted at runtime. And compiled languages may be much faster than scripting languages, but they also require more development time.
Welcome to Python Scripting, brought to you by IBM. In this video, you will learn to understand what the benefits are of using Python. In earlier videos, you heard about several scripting concepts. Let's now apply those to Python. Python, developed in 1991, is a scripting language which uses an interpreter to translate one line at a time. Python is used to develop applications, both web-based and software-based, and while it is not as useful as some other programming languages like C in accessing low-level computer functions, it is increasingly in demand for web applications, GUIs, network programming, and other important cybersecurity applications. Python serves well as a first language that can help you learn other object-oriented languages later on, and can even help you learn languages that technically aren't object-oriented. Learning Python is a great first step in your journey to a cybersecurity career before you move on to Java, C, PHP, or any other language that is commonly used that you've heard about in earlier lessons. The National Institute of Cybersecurity Careers and Studies, NICCS, recognizes Python as useful in a variety of information security areas. Python provides users with libraries full of ready-made functions that make creating applications much easier than starting from scratch. With Python, you as a cybersecurity professional can develop your own analysis tools and hacking scripts and design secure programs. Python does not require users to learn how a computer functions at the lowest level, but is very versatile. Here's our old example of Hello World using Python. As you can see here, it's just print Hello World. You can see from the graph below that Python is recognized as the most popular scripting language based on the PYPL Popularity of Programming Language Index, which is created by analyzing how often language tutorials are searched on Google. Now let's explore the benefits of using Python. The design and functionality of Python provides many benefits to a learner as a first scripting language. Python is open source. Python was developed as an open source programming language, similarly how Linux is open source operating system, which you learned about earlier in one of your courses. The open source nature of Python lends itself to a strong community of developers that support the language and move it forward. Since Python is open source, there is a great deal of information available, and using the language is free. Python is easy to learn and implement. Python was intentionally designed to be straightforward, easy, and generally lightweight, and requires minimal code to accomplish tasks compared to other languages. The fact is that Python often takes substantially less code than what would otherwise be required of other programming languages, such as C or Java. Python's straightforward structure means a shorter learning curve for anyone working with the language, especially those new to scripting. The internet has a lot of free Python resources available, including videos and sample projects would have been included in an additional reading later in this course. Given the massive amount of materials available online for free, just about anyone can gain a working knowledge of Python without taking a formal class. As a security analyst, you will need a basic understanding of the scripting language. Many other IT careers, and as your cybersecurity career advances, you will need additional advanced training. It's also portable, which means it can be used in Windows, Linux, and Unix, and at a high level. What I mean by high level is while Python is general purpose like C++, it has the added benefit of also being high level. High level means more user-friendly, replacing cryptic terms with keywords that frankly make more sense to the human mind. The fact that the structure of Python makes it easier to learn and implement. A straightforward design of Python and ease of use also increases its readability. That increased readability also makes debugging code far more straightforward, which means that even lower level or beginner programmers can troubleshoot and debug their own code pretty easily. And that debugging can take much less time overall to complete. Python can be used for almost anything in cybersecurity. Because Python has a generally short learning curve, it has become the programming language of preference. Because Python has a generally short learning curve, it has become the programming language of preference for those in the cybersecurity field, many of whom have a limited programming background. Python ease of use means that any experienced cybersecurity professional that has built up a relatively strong technical background can learn the basics of Python language and start programming and implementing their code quickly. With a strong understanding of Python and programming concepts, in general, cybersecurity professionals can accomplish just about any task that they need using Python code. For example, Python is used heavily in malware analysis, host discovery, the sending and decoding of packets, accessing servers, port scanning, and network scanning, just to name a few. Considering also that Python is so effective at scripting, automating tasks, and data analysis, it is understandable that Python has risen in popularity as cybersecurity has become more important. Python also has a very extensive library. As we've described above, Python's ease of use is certainly one of the most important factors that makes it a go-to language for cybersecurity professionals. But certainly, Python's extensive language of modules is a leading factor as well. Python has become well known and heavily used because of its extensive library, which means cybersecurity professionals don't need to reinvent the wheel with common tasks, and in most cases can quickly find cybersecurity analysis or penetration testing tools already available. Welcome to Getting Started with Python, brought to you by IBM. In this video, you will learn to describe the basic syntax of Python. Let's get started looking at the Python syntax. Python syntax can be executed by writing directly in the command line or by creating a Python file on the server using the .py file extension and running it in the command line. Indentation refers to spaces at the beginning of a code line. Where in other programming language, the indentation in code is for readability only, the indentation in Python is very important. Python uses indentation to indicate a block of code. The number of spaces is up to you as a programmer, but it has to be at least one. Sometimes you must keep in mind that you have to use the same number of spaces in the same code block, otherwise Python will give you an error. Now let's talk about variables. In Python, variables are created when you assign a value to it. Variables are containers for storing data value. And unlike other scripting languages, Python has no command for declaring a variable. A variable is created the moment you first assign a value to it. In addition, variables do not need to be declared with any particular type and can even change type after they have been set. String variables can be declared either by using a single or double quotes. When we talk about variable names, a variable can have a short name, like X and Y, or a more descriptive name, like age, car name, total volume. There are some rules for Python variables. A variable name must start with a letter or the underscore character. A variable name cannot start with a number. A variable name can only contain alphanumeric characters and underscores. Variable names are case sensitive, such as a lowercase age or an uppercase age, are very different variables. Python allows you to assign values to multiple variables in one line, and you can assign the same value to multiple variables in one line also. The Python print statement is often used to output variables. To combine both text and a variable, Python uses the plus character. Variables can store data of different types, and different types can do different things. In programming, data type is an important concept, which we will discuss next. A few other important syntax concepts to talk about. On the screen here, you can see 3 greater than signs. 3 greater than signs signify example code. For additional syntax, you can check out the PEP8, Python Style Guide. It's a set of rules for how to format your Python code to maximize its readability. Writing code to a specification helps to make large code bases with lots of writers more uniform and predictable. PEP is actually an acronym that stands for Python Enhancement Proposal. Now let's talk about a PY file. It is a program file or script written in Python. It can be created and edited with a text editor, but requires a Python interpreter to run. PY files are often used for programming, web servers, and other administrative computer systems. Finally, comments can be used to explain Python code. Comments can be used to make the code more readable, to prevent execution when testing code and starts with a hashtag so that Python will ignore them. Let's now talk about types. Python has the following data types built in by default in these categories: int for integer numbers, float for real numbers, complex for complex numbers, bool for Boolean values, and str for string characters. Let's go a little deeper into a few of these data types. In Python, the data type is set when you assign a value to a variable. There are 3 numeric types in Python: int for integer. Int or integer is a whole number, positive or negative without decimals, of unlimited length. Float or floating point number is a number, positive or negative, containing 1 or more decimals. Float can also be scientific numbers with an E to indicate the power of 10. Complex numbers are written with a J as the imaginary part. Furthermore, you can convert from one type to another with the integer left paren, right paren, float left paren, right paren, and complex methods. There may be times when you want to specify a type onto a variable. This can be done with casting. Python is an object-oriented language, and as such, it uses classes to define data types, including its primitive types. Now let's talk about Python strings. String literals in Python are surrounded by either single quotation marks or double quotation marks. Hello is the same with single quotes as it is with double quotes. You can display a string literal with the print function. Assigning a string to a variable is done with the variable name, followed by an equal sign and the string. Let's take a look at a few examples. A equals assigns the variable A the value Python basics. A list allows you to store an enumerated set of items in one place and access an item by its position, or index. Using the index in this example, the 7th position is a value of B. Now let's talk about negative indexing. So instead of using indexes from 0 and above, we can use indexes from -1 and below. Assignment of the negative index in this example of -7 is B. You can also use a slice of the index as represented in this example. A3:9, as you can see from the table above, that is equivalent to HON space capital BA. We can see a couple of examples here of arithmetic operator examples. So B equals lesson, then A plus B would be Python basics lesson. If C equals 26, 3 times C would be 26, 26, 26. We also should review some string methods, where A.replace of basics or intermediates would result in a Python basics lesson, whereas A equals A.replace of basics or intermediates, the result would be Python intermediates lesson. You can see different operators available on the next slide. You'll see on this slide 2 different kinds of operations. Arithmetic operations are used with numeric values to perform common mathematical operations, and comparison operators are used to compare 2 values. There are other operators that are also available within Python. Assignment operators are used to assign values to variables. Logical operators are used to combine conditional statements. Identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. Membership operators are used to test if a sequence is present in an object. And finally, bitwise operators are used to compare binary numbers. Welcome to Python Data Structures, brought to you by IBM. In this video, you will learn to describe Python data structures and describe the basic syntax of conditions and branching. You can think of data structure as a way of organizing and storing data, such that we can access and modify it efficiently. A tuple in Python is a heterogeneous container for items. This would remind you of an array, but since Python does not support arrays, we have tuples and lists. To declare a Python tuple, you must type a list of items separated by commas inside parentheses, then assign it to a variable. You should use a tuple when you don't want to change just an item in future, because tuples are immutable. Items within them cannot change. Lists, on the other hand, are mutable. They can change and are separated by commas inside brackets. Sets are mutable or immutable depending on if it is a regular or frozen set accordingly. A set does not hold duplicate values and is unordered. To perform operations on a set, Python provides us with a list of functions and methods. A dictionary uses the curly brackets, just like sets do, but store data as key value pairs instead of a single value, like a set. The keys must all be unique and are paired with the value by a colon. The pairs are separated by a comma. Let's look at if, elif, and else. When you create a program, we almost need to check the condition and change the behavior of a program depending on if the condition is true or false. The simplest condition statement is if. Let us establish the first condition. If it is true, it will perform the task number 1. If it returns false, it will switch to another condition if it is present. If we use the elif statement in our main condition, it stands for else if and checks for multiple conditions. If condition 2 is present and true, it will perform task number 2, and if false, will execute the else condition for task 3. Else is used when none of the previous conditions are met. In this example, we can see we are always going to print hello and how are you. We then have two different if statements. If the variable name is Antonio, it will print hello, it's Antonio. If the variable name is Martina, it will skip that line. The second example shows an if-then-else scenario. If A is greater than 0, it will print A is positive. If it checks A and it's less than 0, it will perform its elif condition and print A is negative. If A is exactly 0, which fulfills neither the if or elif conditions, it will output the else of A is 0. Now we can talk about how to reiterate a task. If you want to print the element of a list, if it's just 3 items, it's easy enough to do. Print 0, print 1, print 2, but if it's more than 1,000 items, what can you do? Loops are there to help with the repetitive tasks. In order to accomplish this, loops use the range function. It's a Python built-in function which returns a sequence following a specific pattern, most often sequential integers, which thus meets the requirement of providing a sequence for the for statement to iterate over. The first loop we'll look at is the for loop. For loops are traditionally used when you have a block of code which you want to repeat a fixed number of times. The Python for statement iterates over the members of a sequence in order, executing the block each time. While loops are different from for loops in that they only run if a condition is met. In this example, we want to print the elements of L until the first negative number appears. The loop will continue to run while the condition is true. As soon as the condition is false, the loop ends. Welcome to Python Functions and Methods, brought to you by IBM. In this video, you will learn to understand functions and methods of Python scripting. A function is a block of code which only runs when it is called. You can pass data, known as parameters, into a function. A function can return data as a result. Python has many built-in functions. You can see a few of them here: type, len, sum, float, print, some of which we've already explored in other videos. In Python, a function is defined using the def keyword. To call a function, use the function name followed by parentheses. Next, we will take a look at arguments. Information can be passed into functions as arguments. Arguments are specified after the function name, inside the parentheses. You can add as many arguments as you want. Just separate them with a comma. The terms parameter and argument can be used for the same thing. information that are passed into a function. A parameter is a variable listed inside the parentheses in the function definition. An argument is a value that is sent to the function when it is called. Why functions? To write our own chain of commands, simplifying the readability. They're reusable and can be used many times. By default, a function must be called with the correct number of arguments, meaning that if your function expects 2 arguments, you have to call the function with 2 arguments, not more and not less. A method in Python is somewhat similar to a function, except it is associated with objects and classes. Methods in Python are very similar to functions, except for 2 major differences. The method is implicitly used for an object for which it's called. The method is accessible to data that is contained within the class. We will learn more about Python libraries in the next video. Welcome to Python Libraries, brought to you by IBM. In this video, you'll learn to describe Python libraries. Python library is a collection of functions and methods that allows you to perform many actions without writing your code. This is just a few of the libraries that are available within Python. Pandas provide high-performance, easy-to-use data structures. NumPy is the fundamental package for numerical computation. It defines a numerical array and matrix types and the basic operations on them. SciPy library is one component of the SciPy stack, providing many numerical routines. Matplotlib is a mature and popular plotting package that provides publication-quality 2D plotting, as well as rudimentary 3D plotting. Seaborn develops heat maps, time series, and violin plots. Scikit-learn is a collection of algorithms and tools for machine learning. And finally, stats models explore data, estimate statistical models, and perform statistical tests. As you can see, a lot of these libraries are grouped together in various different categories. Now we want to look at an application and a goal for that application, which you have a lab exercise that you can do on your own computer. We want to build an application that can do the following operations. It asks to insert a number. It calculates the prime factorization of that number. It prints a dictionary in which the keys are the prime factors and the values are the relative power exponents. It iterates the operation, and it ends if the user asks to exit the application. Check out the lab that's provided and the steps that are provided. Thank you for attending the Python series of videos.